All right, electrorefining. So basically purifying a metal. So if we have a chunk of copper, okay, at the anode, right, we always want the pure stuff at the cathode because that's where reduction happens. So we got a piece of metal, about say 95% copper, but it's got gold, silver, lead, and zinc in it as well. You can throw it into an electrochemical cell to purify it. Okay? So what do we have in that we have to account for? We have water, because it's an aqueous solution. It's a copper sulfate solution. So we've got water. We've got copper solid. We have gold. We have silver. We have lead and zinc. And I guess we have sulfate too. Okay. So we go to the table. Okay, we run electrons, so we're running electrons to the cathode, so boom, boom. First of all, if we look at our data booklet, why did we choose copper sulfate as our solution? Why did we choose sulfates? Why did we acidify with sulfuric acid in that lab that we did? Because it's at the top, it doesn't react. It doesn't want to oxidize, right? It's the second strongest on our data table. Okay? So, second weakest, thank you. Second weakest on our data table. Only fluorine, F minus, is a little bit weaker. Okay? So it won't react. That's the whole point. We don't want that to react. That's why we use that. Okay? So we look at everything else that we have. We've got gold. We've got silver. We've got copper. Lead and zinc. Okay, so when we're looking for the oxidation, right, because we're talking about what's happening at the anode, right? What is happening on this side? This is the anode. Things are oxidizing because electrons are leaving. So we want this chunk of copper to dissolve. All right? Think of it as the lead, the zinc, the gold, and silver are buried within the copper electrode, right? And you have to expose them for things to happen. So we turn the battery on, the electrons start moving. Most of this is copper, so the copper ions dissolve. Okay? You get copper 2 plus in solution, gives up 2 electrons. The copper 2 plus in solution where is it? When we're looking at what's going to be reduced at the cathode, the copper 2 plus is here. It's higher than everything else because we're only looking on this side. This is the cathode reaction, right? The reduction. The copper 2 plus is the highest. It will be reduced, which is good. Okay? That's what we want. So what you get happening is this is pure copper. Okay? So we're taking 95% pure copper and we're producing 100% pure copper. Now, as this electrode gets smaller, these other metals start to pop out. Okay? So when we look at the lead and the zinc, when they are exposed to the electrochemical cell, right, to this aqueous solution, if you look at the table, they are lower, i.e. they are stronger. Copper's here. The lead and the zinc are stronger. So they will be oxidized. Okay? So what happens is you get, I really need a split screen here. The lead 2, the lead and the zinc are oxidized and they go into solution. Okay? That makes sense, right? You still have the copper being oxidized and going into solution because most of this is copper. Okay? There's only little bits of zinc and lead, but they still ionize and go into solution. So, do they migrate over, pick up electrons, and plate out on this? That's the question. Do they? Well, if you look at your data booklet, so now we're looking at the cathode side. It's reverse. Zinc is down here, lead is here, because right, it's picking up an electron, but copper is up here. So what's the preferred reaction that happens at the cathode? It's the copper. So we still get pure copper forming. Okay? Does that make sense? Okay. So the lead ions and the zinc ions just stay in solution. They don't move over. And they're at low concentrations as well.
So what happens when all the copper is used up?
Then it would, theoretically. But then the whole other electrode's gone at that point. But yes, theoretically, if all the copper was used up, then they would start to plate out onto that electrode.
So at the end of the reaction.
So yeah, you would shut it off before it
But
start.
like if you let it run through, then it would just do copper and then like all the other things on top of it.
Yeah, because then they'd start plating out in the order of their strengths.
But can you explain the order thing again real quick?
So, okay, on this, do this for the people watching the video. So this side, this is the anode reaction when you look on the left side, right?
Yeah.
The oxidations. Most of it is copper, so copper's moving out into copper 2 ions. The copper 2 ions then float over to the cathode, okay? Lead gets exposed, all right? Lead metal gets exposed. Lead wants to be oxidized before copper, so it is, okay? So you get lead coming into solution, same with zinc, okay? It's just they're in low concentrations, right? Most of the impure chunk is still copper. So copper is still happening. But then, so you've got lead ions and zinc ions in solution. So say they float over to the cathode. So we're at the cathode. We've got all these electrons there. And we've got copper. The electrons have a choice. They can go with copper, lead, or zinc. What is their preferred reduction? So now we're looking at the left side of the table. Lead, zinc's way down here. Zinc is here, lead is there, copper's there. Who wins? Copper does, right? Does that make sense? So the copper is what these two just stay in solution unless, as Noah said, you run the cell and there's no more copper in solution. Then what would plate out next? The lead, right? Because it's the next highest one. Then once all the lead was gone, then this. Okay, does that make sense? Okay, now, what happens when the silver and the gold get exposed? So we look back here. So pretend all the lead and zinc is gone. They're gone. So now the silver and the gold start to get exposed because this electrode is getting smaller and smaller and smaller. So now the silver and gold pop out. If we look at the data booklet, silver and gold are up here. Most of the electrode is copper. So you have a choice now. We have copper, ignore those, pretend they're all gone. Copper, silver, gold. What will be oxidized? Copper, because it's the lowest on the right side. It's the preferred one. Okay? So these two don't get oxidized. What happens is when the lead and the gold get exposed, they stay as a solid and they fall to the bottom as sludge. Okay? So if you look at the cell, the silver and gold don't get exposed, they just drop out because the preferred oxidation is still copper. Okay, so they just plonk. Again, if you ran the cell all the way and this had an option, the silver and gold would start to after a while, but copper is the preferred reaction. Okay, so what happens is you get solid silver and gold fall to the bottom, a very expensive sludge because it's silver and gold. You get zinc and lead in solution, but they don't plate out because the copper is the preferred cathodic reduction. Does that make sense? And then you just run the cell until you're good. And the overall reaction, so the strongest oxidizing agent is copper 2 plus. That's why it plates out. That's the main reaction. The amount of zinc and lead does increase in solution. Zinc ions and lead ions increase in solution, but they don't plate out onto the cathode here. They just stay in solution.
You said decrease?
They increase. The concentrations of them increase, right? Because, okay. And as they increase, look, then you get into the complexities of this because everything we do is at standard conditions, which is 1 molar, right? These aren't at 1 molar initially, but then they start to come up to 1 molar, and if they increase, go past 1 molar, the chemistry can change as well, right? That's that Nernst equation I think I showed you before. It has the log in it. E is equal to E naught minus a bunch of numbers, log something. Anyway, so the chemistry can change. So it will increase. But the overall reaction of this cell is copper solid, whoops, which is impure, goes to copper solid, pure. We just purify copper, all right? And as most of you I think know, metals are very expensive nowadays. So there's a lot of money and stuff in this. This is industrial chemistry, okay? And how they, what's the word? Optimize this kind of stuff is very important for making, well, if you want to make money and stuff and get purified substances. Oh, there's one other thing. Let's stop here. So that's it for this. We're not going to do the next part.